Welcome back. In this lecture, we will discuss bidirectional search. And so, in most of the searching algorithms that we have looked at, we assumed a symmetry. So, because of this symmetry, we can not only start at the initial node and find a path to the goal node, but we can also do the same thing by starting at the goal node and working backwards to the initial node. Now, what happens here is if you're going backwards, because remember, we're dealing with a directed graph here, the branching factor could potentially be much different going back. And so what happens is if you want to decide whether I should start at the start node or the goal node, if you have information about which branching factor is higher, you could just do the method that takes the lower branching factor, and that'll give you more efficiency. So, however, if we're looking at the case where the graph is being constructed dynamically, or you have kind of a couple different nodes that can be goals, this starts to become more difficult or not even possible. But for now, let's assume that we can do the backward search. Here's another idea that can be used to reduce time and space complexity. And so why not do searches from the start node and the goal node simultaneously and kind of have them meet in the middle? And so if you can do this, if you can figure out that meet in the middle part, you're going to cut that exponent in half, and now you just have this constant factor of 2 in front. So this is a really big savings in terms of time and space complexity. It's an exponential savings. However, we got to make sure that the frontiers meet, and that's kind of the tricky part here. So if you're using it with breadth first search, one idea is build up a set of states that can quickly lead to the goal, and going the other direction, going from the goal node, try to reach one of those intermediate states. So how much you store, this can also be tuned based on available space. So stay tuned. We'll explore these ideas a little more in subsequent lectures.